Hi there, and welcome to this tutorial for motion matching for Unity. In this tutorial, we're going to learn how we can achieve strafing with motion matching. Strafing is a bit more challenging than normal locomotion because you tend to need a lot more transitions and stuff like that. Now, the first thing we need to look at with strafing is the trajectory. So I'm going to turn on my gizmos now. And let's have a look at what happens when we're not strafing. So when we're not strafing, you'll see that the arrows in the green trajectory face in the direction that I point the stick. This is following your nose. It's a kind of animation, kind of gameplay where the character always faces the direction you're going. Now note what happens when I hold down the strafing button. No matter which direction I push the stick, the arrows keep facing the same way as the camera. As I rotate around with the camera, it also faces the same way. So the first thing we need to do when we look at strafing is turn this feature on the trajectory generator. Let's have a quick look at that. Okay, so here we have our MXM trajectory generator, and you'll notice under motion settings there is an option to toggle on strafe. Now this is just the default setting, and most of the time you're going to want to set this at runtime unless your game only strafes. Then you can just click this and leave it. So let's have a look quickly at how we can turn the strafing mode of the trajectory on and off. One last note before I do, we need to slot our camera transform in here so that the trajectory generator always knows which way the camera is facing, so it can match that with its strafing. So let's go to our player controller script here that I have for the demo. Don't worry about what the script does, but just have a look at how we turn that strafing on. Now I've got this m_mxm controller. This is a reference to the MXM trajectory generator, which I just get in the start function. And I can simply set strafing to true or false by choosing MXM controller.strafing equals true or false. Very, very simple. So that is the first part of setting up strafing with motion matching. So the next part is to actually add our animations into the preprocessor. However, we need to really think about this step, and I'm going to do a few illustrations so we can understand why we might do it some ways and why we might not. So let's start with the most basic approach. So if we have our character that's in the middle here, and we're looking at him top down, he's facing that way, for example, we can get all these different strafing directions. So a typical strafe set of animations, you'll have your forward, you'll have your back, left, right, and you'll have all your in-betweens. Okay, so that's pretty good. Now, if we were to just chuck in each of those animations individually, we're going to have a little bit of a problem. It will work, however, it's going to be a bit jumpy, because what about all this space in between? Now, motion matching isn't like a state machine. You don't blend values constantly in general, so it's going to jump between these different directions quite harshly. There will be a blend, but we're going to miss out on all that stuff. So the next option we can do is go, well, why don't we use the blend space system? So we'll put all the animations into a single blend space, and if we draw like a rudimentary blend space, we've got our character in the middle, and we're going to have, this is the y-axis is 1, -1, x-axis 1, -1. And we put all our animations, we put our animation here, 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 etc. So this is one way you could do it. However, it's not a very good way, and the reason is quality. The purpose of motion matching is quality, and if we're going to blend all these animations together, we're going to lose our quality and we lose the purpose of using motion matching. The problem with this kind of blend space, and this is actually the same for Mechanim as well, is that you're going to get blends of a lot of different animations. You could get up to 4 different animations blending. Say, for example, if you're somewhere here, you might get some from this one, this one, this one, and this one. That's not very good. What tends to happen with this kind of things is that in certain situations, in certain points in the blend space, we end up getting leg crossover, and we don't want that at all. That is terrible. So let's go to the last way we could do this, and it's still with blend spaces, except we're going to split things up a little more. So if I get my character and these in the middle, we're actually going to break things up into 4 blend spaces: north, south, east, and west. So our north blend space, we're simply going to have 3 animations in each blend space. But because of the way we're setting them up, and they're going to be 1D, it's only ever going to blend 2 animations together. So we have a blend space here, here, and I'm going to actually set this up in the editor. I just wanted to illustrate this first, because sometimes it's easier to just draw the stuff. So we're not even going to use, we're only going to use one axis at a time. So in our north blend space, that's for you moving generally in the northern direction or forward. So we'll put our walk forward in the middle here, or our run forward, or whatever speed we're going. We'll put our 45 right here, and we'll put our 45 left here. Okay, so now we're, the general northern direction is like that. In our south one, we're going to do the same thing, except it's going to be the opposite. So that's blend space number 2. With our east direction, we're actually going to use the y-axis only this time. And what I'm going to do is, in the middle we have the east, and then at the top we'll have that, and then the bottom we'll have this. Now this is actually a takeaway for any animation. If you're want to learn a bit of technical animation, this is a better way to split up blend trees and blend spaces for AAA animation, rather than having that huge dial, which is actually taught by default by Unity, which is a bit of a problem. So we'll go left here and like this. So here we have our 4 blend spaces, and we're going to use scatter spaces here, and we're going to have this one set to scatter X. This one's also going to be X. These are going to scatter in the Y because we've set them up in the Y, and therefore we don't get this massive amount of poses because we're doing a 2D blend space and we're scattering it. Don't worry about that, but it's also more performant to do it this way rather than the single blend space. So let's go into Unity and actually set this up. Alright, so I've already got these set up. One for strafing in combat and one set of 4 for strafing while walking. But we're going to just set one up, an additional 4 of these up, just so that we can get some idea. So let's go for our walk forward. Walk forward is part of strafing. And let's drag that into blend spaces, and we get a new blend space, and let's double click on it. We've automatically got our walk forward loop in the middle of the animation there. So let's go find the other parts. So of course we had left 45 and right 45. We need those as well. I've got a lot of animations here, so bear with me as I try to find them. Okay, so I've got my strafe left 45 loop here, and I'll drag it in and I'll put it on 0 but on this side of the x-axis. And we'll go for our strafe 45 right loop. And there's my strafe right 45 loop, and that's the first blend space, but we need to change it from standard to scatter X. And we want the spacing to be around 0.05. I found that was a pretty good sweet spot for scattering samples of this blend space. So that is our north blend space. Let's now do the south, and we need for that walk backwards loop. Drag that in, open that one up, got a backwards loop. We need strafe right 135 and strafe left 135 for that one. Again, we'll change this to scatter X, make sure it's 0.05, that's pretty good. Okay, now we need our strafe left loop. Strafe left loop, drag it in, double click on that. Now we need strafe, we're going to need both of our strafe left. So strafe left 45, that's going to go up. This time we're using the y-axis. You can technically use either one, it doesn't matter. It just, this looks more logical to me if I'm thinking about looking from top down. So strafe left 45, and I need strafe left 135 at the bottom. And onto our last one, we need a strafe right loop. Drag that in, and we'll do the same thing. We've got strafe right 135, and we've got the other one, strafe right 45. Again, we'll change this now to scatter Y and make sure it's at 0.05 or something pretty low like that. I think I missed doing that for this one. Yes, I did. So I'll turn this one to scatter Y as well, and 0.05. Now, in my system, I'm using lots of different styles of movement. I've got strafing, I've got running, I've got combat. So I'm using tags to differentiate strafing. I mean, your game might always be strafing, so you might not have to do this, but if you are, then you need to use required tags. So I've already got a strafe tag set up, so I'm just going to mark all of these with strafe. Now, if you don't know how to do this, go back and watch the tagging tutorial, specifically required tags. I'm not going to repeat myself here because that'll take a while. So basically, I'm going to mark all of the ones that I just did with strafe tags. And now these blend spaces are completely set up and ready to go. All right, now we have our blend spaces set up, but this only contains the loops for our strafing. Again, I've said it 100 times, motion matching needs transitions. You need to have your transition animations, as many as you can possibly get your hands on. So we still need to set those up. Fortunately, setting up the transitions, so it might be strafe right start, strafe left start, strafe back start, walk forward start, all of those, the stops. If you have plants, if you're lucky enough to have plants, that will help too. We're just going to set them up just like you would with any other composite. So I'm just going to show you what I've done here instead of doing it again, because we've already talked about this in other tutorials. So let's go to, where's my strafe category? So I've got walk forward start here. You can see I've got walk forward start in the front. I've got a walk forward loop in the after animation. And in this case, I'm using runtime splicing. Now, just remember that with runtime splicing, the animations have to go from one to the next smoothly and perfectly without any blending. Kubold's clips do this. Not all animation sets do this for some reason, and it's kind of strange. So just be aware of that. But we're basically setting this up just like we would a normal walk forward start composite. Though in my case, I am having to tag this with strafe. I've got the same thing with stops. The walk forward loop is now in the before animation, so we can calculate that trajectory. Again, strafing. Walk backward start, walk backward stops, walk left start, walk left stops, walk right start, walk right stops. Now, to get this absolutely 100% perfect, you would want more animations than this. And it's really worth actually making these or trying to source them if you can. Even if you are making them to be like not as good as the originals, just a dirty blend, it would be better because we don't have any 45 starts or stops, which is annoying because that would make it really smooth. And we also don't have any plants, so like left to right plant. That would be really good. And when you if you were to do a mocap set, you would capture all this. You would capture all these different movements, and you would get this really fluid human motion that really isn't possible when you have a limited amount of clips. However, let's look at how we can overcome the lack of these transitions now. So we can pre-process this at any point, and we will get our MXM anim data, and that is where we're going to look at calibration. Okay, so I'm looking at the MXM anim data that we just pre-processed from our preprocessor, and this is where the calibrations are. You can see I've got a lot of different calibration sets for this particular character. I've got separate ones for combat and strafing and crouching, because movement is different in different types, so it's going to need different calibrations to be better. One size does not fit all in this case. So I've got my general locomotion here, and then I've made another one called strafe. If you need to make another one, by the way, you can do that by clicking Add New Calibration down the bottom, and you can just rename it as you like. So what is the difference between general and strafing? Well, if you do have really fluid motion, maybe not so much. However, if you are missing transitions, we're going to need to calibrate in a way that's going to help it. And you'll see there's some pretty big differences between the two. Specifically, the strafe favors trajectory over pose, because if we don't have the transitions, there's big jumps in pose. So to allow the system to make those big jumps, we need to say, no, trajectory is more important than the pose, because we want it to be responsive, and trajectory is all about responsiveness. So I'm just going to point out a few things. I'm going to go more in detail on calibration itself in a different tutorial, but we'll just touch on a few things here. So first thing, let's look at the trajectory. The angle So the trajectory is broken into two parts: the position of the points in that trajectory, and also the angle of those positions, the arrows, the way the arrows are pointing. Now, obviously, what makes a strafe is that it's facing in a specific direction. So, I mean, technically it's possible to do strafing without tags by just having the angles of the trajectory correct, but I like to be a bit more explicit with and use tags. But it's still really important to have this angle multiplier pretty high. So I've chucked it up from 0.06 from 0.05. I've also chucked up the position multiplier, so how important the trajectory positions are, to 10 instead of 8. Now, this, of course, will be different for different animation sets. I'm just trying to explain the concept of how the trajectory is more important in strafing, especially if you're missing transitions. Another thing you can see is the pose trajectory ratio. I've pushed it another 0.1 from 0.7 to 0.8 in favor of trajectory. So you can see there's more trajectory going on there. I've reduced resultant velocity weight to 0.1 from 0.15. The pose weight, it's more or less the same, and the body velocity weight to 3, from 3 to 1.5. And this is kind of important because, as I said before, we don't have any plants. So if we suddenly change direction, that's a complete opposite velocity, and the system might struggle to jump that gap. We're not even going to look at the joints. In fact, we're going to give the joint weightings the exact same importance as the previous. It's just these overall weightings. So you can see, all in all, while I've changed a lot of different settings here, I've basically just made trajectory that much more important. So if you are like me, you're going to have your separate calibrations and you're going to have your separate modes of running, strafing, and running in directions. You're going to have to change your calibration at runtime. If your game is just constantly strafing, you just make that your base calibration. But if you do need to change the calibration that the system is using at runtime, we can do that pretty easily with one function call. So if we look here, we just need to get the MXM animator component, and we can call set calibration data, and we can pass in a string, which is the name of the calibration. I've already got it here in this begin function, begin strafe function, but I'm actually passing a cached name. That's the only difference there. So you can do that within your game logic however you like, whenever you begin strafing or whatever. Okay, so there's one last thing that we really need to consider before we are done. Now, none of our animations actually do strafing arcs, and it would be quite unreasonable to have strafing arcs. Therefore, the character actually needs to be rotated procedurally. Now, there's two ways you could do this. You could do this with your own code, just rotate the character procedurally based on the camera rotation, so that you're always looking in the direction of the camera. We don't have to worry about the trajectory because remember we already set it to a mode where it's already going to look at the camera and figure that out. But we do need to rotate it. So you can either do it yourself, or there is one other way with trajectory error warping. And if you don't know what that is, then please go and watch the previous tutorial where I go into that in detail. So let's have a quick look at the settings that we need that for strafing. So if we go to our MXM animator and we go to this warping tab, we will see angular error warping. We want to keep it on procedural. And when we're strafing, we want to change the warp method to trajectory facing. And by default, it's current heading, which is when you're following your nose. But we want to change that for trajectory strafing so that the system will automatically procedurally rotate the character to match our future trajectory facing angles. Now, the warp rate is how fast the rotation is going to be, and the other settings, you should just go and watch the previous tutorial to understand those. All of these settings can be changed at runtime, which is necessary if you're going to switch into strafing. For example, in my code, I have this function when I begin strafing, I set the calibration data, I change even the speed of my trajectory generator and all that. That's out of scope for this video. But you see here, I'm changing the actual angular error warp rate and the warp threshold. I can even set the method. So angular error warp method equals angular error warp method dot, and then you can change that to trajectory heading. And then when you finish strafing, you change it back to current heading. Of course, if you're using both types of systems. So that is how you can do that. You want to set your angular error warp rate really quite high if you want to have it to have, to really quickly follow your, camera angle. So that is pretty much it for strafing. This is probably the first tutorial where we've looked at more than just a feature in how to do a certain type of animation using a lot of features. So as the tutorials get more complex, we're probably going to do more tutorials like this where it's more of a practical approach. We'll use features that we've already learnt about to make something bigger. Thank you all for watching, and I will see you in the next video.